we are going to learn about most preferred Python library for data science. It is called Pandas. Well, Pandas is an advanced version of NumPy. Let me tell you a few differences between NumPy and Pandas. So in NumPy, we create vectors and matrices. But in Pandas, it is we create data frames and series in Pandas. So what are data frames? Well, data frame is a combination of, basically we can use custom index values in data frames, like employee ID as a column name, employee name as a column name. But for matrices it is not possible. We cannot have different columns with different data types in matrices. For example, um, suppose we have created a identity matrices. So what it will do is it will create the combination of 6 rows and 6 columns, and where the one will be in diagonal position, and all others will be 0. So but in data frame we can have different column with different column names, like employee ID, as I already told you, employee name, employee address. It is not possible for matrices. Then data frames contains heterogeneous series of data types. Heterogeneous series of data type means it can contain, in one data frame it can contain a string, integer, float, boolean in just one data frame. While in matrix it is a homogeneous combination of data types. It can only contain string, or it can only contain integer values. So, and one more thing, when we create a vector, it is always displayed in a horizontal position. So whenever we create a vector, it is always a horizontal in the output. But when we create a series, it is always a vertical. If you create a vector 1, 2, 3, 4, it will always display it as 1, 2, 3 and 4. But whenever you create a series, it will always displayed as 1, 2, 3 and 4. Let's talk more about Pandas. Okay, so Pandas library. It is a most preferred library for data scientists. It is used for data manipulation. We can manipulate the data. We can make changes. We can add columns, delete columns. We will see later how we can do it. Then it is used in pre-processing of data. It is used in analysis. Well, Pandas is a best library for analysis, data analysis. Now, data structure, column, insertion and deletion. In a data structure, in a data frame, we can insert a column as well as we can delete a column. Then it is used for merging and joining, or joining of two different data sets. Then it also provides a data filtration. We can filter the data as well using the Pandas library. We can also concatenate the different data types. We can also concatenate 2 or more data types. Then data, it is used in data selection. Whatever relevant data is for us for our analysis, we can select the data, and then it can help in data exploration. It is also very useful in handling missing values in a complete data set, and also we can handle duplicate in our data. Then in Pandas we work with series and data frames. In NumPy we work with vectors and matrices, but in Pandas we work with series and data frames. We will learn more about series and data frames in our next sessions. Then data frames contains heterogeneous series of data types like integer, string, float, boolean and so on. Then it is very useful in reading files in different formats like Excel, CSV, JSON, HTML, SQL, SAS, SPSS, etc. So what is the syntax to read a file? We use PD or pandas dot read underscore CSV. So this is just an example. I want to read CSV file. We can use this read underscore CSV and bracket. So now let's go to our Jupyter notebook and work on Pandas library. I want to install my Panda library. So it is already installed in my system. You can use this code and install Pandas. First, just go, and because we have already downloaded Anaconda, so guys, I think it is not required. Just go to line number 2. First import Pandas. It is inbuilt library in Anaconda. Just in case you get an error, then go with this line. Okay, so I want to import Pandas. I am giving it alias as PD, and then shift enter to execute it. Okay, now I want to create a series. How we create a series is, this is my name of the series, then PD dot give a series, and then whatever you want to print in your series, give those values. Now I want to print my data. You can see here it is displayed in a vertical position. Vectors are always horizontally displayed as an output, but in series it is always a horizontal position with index values. You can see here these are the index values starting with 0. Okay, now I don't want my default index to be displayed with my series. I want to change the index name. So what I'll do is, I'll give index is equals to whatever name I want to give. So I want to give A, B, C and D. So let's print this, and then you can see here A is printed against 1, B instead of 0, 1, 2, 3, I have given a name to my indexes. Now in series we can convert list, we can convert list or tuples into series also. Let's see how we can do it. So my index is CDE. I want my index to be CDE. Then list, my list name as LST, and the values are 1, 2, 3. Now I want to convert this list into series. So what I'll do is, I'll give data is equals to list. So let me show you one thing why I am giving here data is equals to list. When you let me insert a cell. So data 1 is equals to PD dot series. Okay. Now just move your cursor here and then press Shift Tab. You will get to know all the what all functions we can use in our series. So here you can see, first we have to give the data name. Data is equals to list. I want this data to be converted in series. So data is equals to list. Then index is equals to none. But I want my index to be printed as CDE. So I am giving index as INDX. I don't want my default to be printed. If you give here none, then the default 0, 1, 2, 3 will be printed. Now data type. If I want to convert this, if I want to print this as a data type int, or I want to print this as a data type float. So here I have to give my data type. Then name none. So you can also see the description over here for all the parameters, data, index. So this way you can see what all the parameters are included in each function. Just you need to, let me write it here. You just need to enter Shift plus, you just need to press Shift plus Tab to see the parameters. Inside the function. Okay. Now in Pandas, let's see how we can read the data. Suppose we have millions of data or thousands of, let's not go to millions. Let's see, we have thousands of data in our data set, and that is into different formats. Maybe I must have maybe it is in Excel format, or maybe it is in CSV format, or maybe JSON or HTML. So how will we read it? Let me add one. So let's see my data. This is the name I am giving to my data frame, which I am going to read it. So I'll not use this complete function everywhere, this complete statement everywhere. I'll only use this small name df1. pd dot read underscore shift tab read underscore excel for let's see, read underscore csv. I want to print. I want to read one of the CSV. So what I'll do is, the function is read underscore CSV, and then you have to give your CSV file name. For example, this data is my CSV file name, then dot CSV. Okay. See, one more thing. I can, if my data is in my working directory, if my data set is in my working directory, so I can directly give this my file name and it will read my file. Well guys, my data is not in CSV, so I am just going to show you what is a syntax if I want to read a CSV file. Now my data is in Excel, so let's see how we can read an Excel file. So df is equals to pd dot read underscore excel, and then give your data name. This is my file name dot, you have to give this dot and the XLSX for Excel, to read the Excel. Okay, one more thing. Suppose I want to read data from a different sheet. There are multiple sheets in my Excel file. So what I'll do is, you have to write a sheet underscore name is equals to double quotes, and here sheet 1 maybe. So whatever the sheet name you have, so just mention it here and then read that file. I don't know which sheet name I have, or just do one thing. Let me comment this. It won't read, but this code will be useful for your future understanding. So I'm not going to delete it. Let's remove this from here and let's read this data.xls file. You can see it is executed. Now I want to print my data frame df. You will see that I have 2000 rows in my data set df, data frame df, and 21 columns. It is all not displayed here. You can see top 4 and the bottom 5 over here, and you can see the battery power. You can see all the column names are displayed here. If you scroll here, all column names will be there. Then these are the index names 0 to 1999. So I have 2000 rows starting 0 and 21 columns in my data set.